We're going to be talking about polygons. Now, what poly means, just poly, means many. And gon, what it means is sides. So we're going to be talking about figures that have many sides. Now, in polygons, the side must be a straight side. I cannot have curves. So an example of a polygon, I have a figure that has three sides. So notice it has three sides. And another rule that we must have in a polygon is that they all must be connected. All the sides must be connected. So an example of not a polygon is that even though they're straight, it's not connected. And another polygon I can have is something like this. Right? All the sides are connected and they're all straight. A circle is all connected. Let's assume that's a circle. Circle is all connected, but it's all of a curve, not a straight side. So it's not a polygon. The polygon have sides and they're all connected and they're all straight. Let's talk about the names first. Let me start by talking about the name. Smallest amount of sides a polygon can have is three sides. Now, when we have a polygon with three sides, we're going to call that triangle. Any polygon with three sides, we're going to call it triangle. Now, one that has four sides, and on your mind, many names can come up, like a square, like a rectangle, a kite, a rhombus. There's many shapes of with four sides. Now, we're just gonna say that if there's a shape that has four sides, all of them we're gonna call it quadrilateral. So quadrilateral. To help you guys a little, you guys have seen the bikes quads. The motorcycle quads. They're called quads because they have four tires. And lateral means side, so quadrilateral. Now, starting at 5, we're going to be using the word gon at the end, for polygon. Now, for 5 sides, you can think of a building that's in Washington, D.C. that has 5 sides. That building is called Pentagon. Penta means 5, so Pentagon means 5 sides. For 6 sides, we're going to use the word hexagon. For 7 sides, we're going to use the word heptagon. Now, for 8 sides, I'm even going to help you a little. There's the UFC. You see, they're fighting a ring that has 8 sides, and their ring is called octagon. Octagon means 8 sides. Now, as a matter of fact, the UFC has what we call the regular octagon. Now, regular means all the angles and all the sides, right? All the sides have the same length. All the angles have the same length. That's what makes it a regular. Now, octagon just means 8 sides. It doesn't matter if the sides are different length, but 8 sides equals an octagon. Now, for 9 sides, we're going to call that nonagon. For 10, let me think of the word. If you can think of the word that means 10 years. Because what 10 years, that's a decade. So we're going to call this decagon. For 11, we're going to call those on decagon. For 12, we're going to call the word dodecagon. Those are the names we're going to be using. A polygon can have more than 12 sides. It could have many. As a matter of fact, let me think of one. I could draw a polygon that say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So see, I can come up with a polygon. In this case, has 15 sides. So see, it has more than 12. Any numbered after 12, I'm just going to use n gon. N will be representing the number. My example here, I have 15 sides, so I'm going to call that 15 gon. If I have a polygon, I can draw a polygon that has 100 sides. I'm going to call that 100 gon. So anything after 12, I'm just going to use that number. But let's take a look. Question number 13. Write the name of each polygon. Let me count the sides. I have 1, 2, 3, 4, 5, 6, 7. Let me write n equals 7. For me to remember, it has 7 sides. So the way I'm going to call this, I'm going to call it heptagon. It has 7 sides. Looking at question number 14, I'm going to count it. Let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I know it has 9 sides. I'm going to call this nonagon. So depending on how many sides, I'm going to give the name to it. Another thing that polygons have is what we use a concave or convex. There's something that we call diagonal. A diagonal in a polygon is when I connect two corners, and I connect two vertices. A corner is it's a vertex, plural is vertices. So when I connect two corners, with the exception of the sides, obviously, when I connect two corners, that is what we call diagonal. Now, if I can think of a diagonal that part of the diagonal goes outside of the picture, I'm going to call it concave. If I think of all the diagonals possible, but none of them go outside of the polygon, then I'm going to call it convex. Looking at number 15, I can think of a diagonal that goes outside of the picture. Because I can think of one diagonal that goes outside of the picture, this is called concave. There are many other diagonals. As a matter of fact, that's not the only diagonal that goes out. I could even think of, let me draw another diagonal. I could even think of this diagonal. Seems like it goes out a little. So as long as I have a diagonal that goes outside of the picture, at least part of it, it's already concave. But remember how it came in and said, oh yeah, I can clearly see that one goes outside of the picture. So because of that diagonal, I'm going to call it concave. Now looking at number 16, I could think of many diagonals. There's one. I could even draw many diagonals, but I noticed that none of them go outside of the picture. I cannot think of a diagonal. Let's assume it connects that corner. I cannot think of a diagonal that goes outside of the picture. I keep on drawing them, but none of them go out, not even a little part of it. All the diagonals in this case are inside of the picture. So I'm going to call this convex. If one diagonal happens to go out of the picture, concave. If no diagonals go outside of the picture, convex.